Yes. Rational expressions. Today is September 9th. Remember, tomorrow and Friday are thank you, class composites. Alright, a rational expression is a fraction where the numerator and or the denominator are expressions. Okay? They're really all expressions, but not the way that you tend to think about them. Examples like x over x minus 3. X squared minus 4x minus 21 over x squared minus 1. Those are rational expressions. Yes.
Your enormous brain is blocked. Okay. Get some more. I know. Don't laugh at me on the stupid.
Alright, so numerator and or the denominator are expressions. Now this means, what does this bar right here mean? Divide means division, okay? And we can divide by anything that we want to except 0. Cannot divide by 0. Division by 0 is undefined, okay? It can't be done. So that brings in some domain restrictions. So in everyday language, domain restrictions basically are things that x can't be. Because if x were these things, we would be dividing by 0. So they're things that x can't be. So, like in this first one, x over x minus 3, I can't divide by 0. So what can x not be? 3. Because what happens if x is 6? 0, and I'm divided by 0. So that one can't be 3. Now over here, it's a little bit tougher. Can't be 3 or negative 3. Right. See, this one would have to be factored out. See, there was a reason we factored this week and we didn't rational expression. We factored last week and rational expression this week. X can't be 3 and it can't be negative 3. Because if it's either of those, I'm going to end up with a 0 in the denominator. That's not allowed. Okay? Can I move this one? Alright, let's look at this. 3x over x squared minus x minus 2. Right. What values of x have to be excluded from the domain of this problem?
Minus 3 and positive 2.
What?
Minus 3 and positive 2.
Minus 3 and positive 2. No.
Oh, sorry.
Factor the denominator. Factor this. What's that going to factor to? Okay. So x can't be 2 and x can't be negative 1. 2, we have a 0. If x is -1, we have a 0. And 0 is not allowed. Right? Can x be 0? Can I put 0 in here? Yeah, because I'm going to end up with 0 over -2. Your answer can be 0. You cannot divide by 0. Okay? There's a difference. If I put the actual number 0 in, that's okay. 0 on top, that's good. If I put in 2, 6 over 4 minus 2 minus 2 is 6 over 0. That's undefined. Okay? That is bad. This is okay. That's bad. You see the difference in having an answer of 0 and not allowing the denominator to be 0. Because people tend to get these confused. Like you just see a 0 and you get scared and you run. Okay? You don't have to do that. Look at the factor. Let's give it one more to try on your own. Alright, find out the domain of that expression. So we have to factor the denominator. What does it factor to? X plus 6, x minus 5. So if I'm talking about restrictions here, x cannot be what? Exactly. Very good. Good. Now let's talk about simplifying rational expressions. Look at this one in blue. On this fraction, 24 over 64. That's a fraction, right? This is a fraction. How would I simplify this fraction? Divide by 8 to... Basically, I really want to divide by its greatest common factor, right? So, 8 does go into both of these. So that, when I take out the common factor, I get 3 over 8. That's how I simplify this fraction. That's how I'm going to simplify this fraction too. I'm going to look at their factors and see if they have any in common. And if they have them in common, I'm going to take them out. I'm going to cancel them out. Okay? So in order to find out if they have any factors in common, I have to factor them. Factor the top, bless you. I have to factor the bottom. Alright, so factoring the top. let's rewrite it. Doesn't have to be rewritten, but I know a lot of you really want to see it in this order, so that's how we'll look at it, okay? It doesn't have to, you can look the other way. So can you think of two numbers that when multiplied equal a negative 21, but when added equal a positive 20? 20 and 1? That's going to multiply to equal 20. 21. Okay, that'll work. 21 and 1. We're going to make that one the negative, so I get a positive 20 out of it. Okay? So a negative 3x squared minus 21x, no, sorry, plus 21x minus 1x plus 7. And take out a negative 3x, x minus 7. Got a negative 1, x minus 7. So my new numerator is going to be x minus 7, negative 3x minus 1, which I really don't like the look of that. I'm probably going to change it in just a minute. But we'll keep it like that. Alright, let's factor the denominator. Two numbers that when multiplied give me a negative 42. When added, give me a negative 11. What? 6 and 7 don't give me 11. 14 and 3 do though. You double the 7 and half the 6. That'll work. So 2x squared minus 14x plus 3x minus 21. Take out a 2x and I'm left with x minus 7. Take out 3 and x minus 7. So my new denominator, which isn't new, it's just written differently, x minus 7, 2x minus 3. Do they have a factor in common? Yeah, so just like this is a regular fraction, you can cancel their common factor out. I'm going to take this negative. I don't like negative. I'm going to do this. There's your simplified answer. It would be right. Later on it might end up haunting you, so you might just get in that practice. You have that written down? I'm going to give you one to try, a little bit easier one. I'm going to give you one to try by yourself. And then when you get that one, I'm going to give you a tougher one to try by yourself. Some people are still writing this stuff, so we'll wait a second. Alright. This one is yours to do. That's 6x cubed minus 15x squared, 12x squared minus 30x. Okay. What can I... Okay, these are not trinomials, so I'm just going to factor out a GCF. So what can I factor out on the top? 3x squared. And that will leave 2x minus 5. What can I factor out on the bottom? 6x. And what does that leave? Alright. So right away, I know these are going to go, right? That's going to leave me with 3x squared over 6x. Except doesn't that reduce to? Yeah. Uh-huh. That's a 1 and that's 2. So it's going to leave me with just x over 2. Sorry.
And trinomials.
You get a pass today because you took the snake out of the room, so.
No, I'm gonna get past being stupid.
You used all your brain to wrangle a snake and remove it from the room, so you're safe.
Like last week, I killed like a piece of the garden.
You have it written? No? Alright, this is the next one. This one is back to a trinomial. 3x squared plus 10x minus 8 over 8 minus 14x plus 3x squared. Alright, on top, I need two numbers that multiply to equal negative 24 and add to be 10. Negative 2 and a positive 12. So that's going to be 3x squared minus 2x plus 12x minus 8. I can take out an x, and I have 3x minus 2. If I take out a 4, I'll have 3x minus 2. So my numerator factors to x plus 4, 3x minus 2. Alright, denominator, I need two numbers that will multiply to give me 24 and add to be a negative 14. Negative 2, negative 12. Right, okay. So, 8 minus 2x minus 12x plus 3x squared. Here I'm going to take out a 2, and I have 4 minus x. Here I'm going to take out 3x. I have negative 4 plus x. Okay. What's different about these two? What's different about this and this? They're flipped and the signs are different. Yeah, I need them to not look like that, right? Now I can rewrite this one as x minus 4, and that looks great. But what's going on over here? Yeah, it's a negative x. Since I'm trying to cancel things out, right now this is 3x plus 2. Could look a lot like that one if instead of taking out a positive 2, I make that a negative 2. Now I have two factors, x minus 4 and 3x minus 2. Okay, so these two are going to cancel, and I'm going to have x plus 4 over x minus 4. Those aren't the same. I can't make them look the same. Like this one, I can make it look the same because I just changed the sign of 1 on this side. I can't change those signs and make them look the same. That's the answer. One more thing I want to show you. And then I think it'll probably be top of the hill. We're going to divide these rationals.
Was the answer x plus 2 over x minus 4?
Yep.
Yep.
Now let's take it back, way back, to like 4th and 5th grade. Do you remember how to divide the fraction? Flip and multiply. Flip and multiply. 2/3 times 4/5. So you would end up with 8/16. Same thing happens with this that happens with this. Same thing happens. You flip the second one and multiply. It's just that this one has a lot more factoring than this did. And reducing fractions, these fractions are easy to reduce when you compare them to these fractions. Okay? Okay, I'm going to go ahead and flip, then factor, because there's less to move around. After we factored it and it's all expanded, there's lots of little pieces. It's easier to flip it first and then start factoring. So I'm just going to rewrite it. Times x cubed minus 3x squared plus 9x over x squared plus 7x plus 12. Okay, so let's start factoring. Right here, does anybody recognize what this is? It's a perfect square trinomial. Yeah, this is going to factor to x plus 3 times x plus 3. You may recognize what this is. Sum of two cubes, where a is x and b is 3. So it's going to be x plus 3, x squared minus 3x plus 9 times, this has a GCF of what? What do all of these have? They're all x. X squared minus 3x plus 9. And what are two numbers that multiply to give me 12 but add to give me 7? 4 and 3. Okay, when it comes to canceling, you can cancel straight up and down, and you can cancel diagonally. So these are gone. X plus 3's are gone. Yep, those are gone. And I'm left with just x over x plus 4. The hardest part is the factor. You've got to be able to factor. You have to be able to factor. If you still can't factor, then you need to look up some videos. You need to go to Khan Academy. You need to go to YouTube. Whatever. You need to practice factoring. You've got to be able to do it. Okay? You've got to be able to factor. All right.